Alright guys, so we have a problem with the 1000 MP Mark V field, and it's off frequency. So it looks pretty good on 80, but when you get down up to 10, as you keep going up to the bands, it gets worse. And it's off by about 10 hertz on 160 and 80, and it's off by about 100 hertz. Or I'm sorry. Let's see, what would the number be? So if I'm on 2843.1, so that's 130, 100. Yeah, it's off by about 100, and then 10. So between 10 and 100 hertz, which is not a lot, but it's noticeable on 10 meters. So if we can get it a little bit closer, we're gonna go ahead and do that. I cannot remember if this has the TCXO or not. I didn't think it did, but I can hear it do something when you turn it on that sounds like a TCXO oven warming up. And it might have it, and I just thought it didn't. The case can be kind of hard to split on these. You got to pull both of them because the damn thing's on the side of it. So I'm just doing this for the sake of the video to tell you what we're doing. I don't even really need a frequency counter to do this as long as I have a known very accurate radio. The problem with a lot of these radios that are more than a few years old, even my FTDX 3000 was off frequency, my 1200 was off frequency. Probably as far as modern radios, the problem with the 710 is that it has like a certain amount of latency in it, and you'll hear it. And maybe I'll do that in the video and show you. This radio is pretty large as far as radios go, so you have to be careful with it. There's not like an excessive amount of screws or anything in it like some radios. What's weird is it's about the same size as the 920. The 920 doesn't have any feet or a handle, and it doesn't have a spot where you can even put them. But this does, but I guess that's probably because it's called the field. Okay, let's see if we can get... Oh, we got to get all the back screws. I'm going to try not to do is slide it around on its feet and tear up the little feet things, because they have a little cushion on them with some clear plastic, and they get bad if you tear them up really bad. So sliding them across a wood bench like this would be bad. Okay, there we go. This radio's been opened before because somebody lost one of the screws that sits behind the handle. It does not want to come undone over there. I've already got it right here where it's like pretty loose. It's acting like it's stuck right here. I thought you didn't have to take the handles off. I guess you do. I may be wrong. Yeah, it looks like it goes all the way through. Okay. Yep. Boy, it boogered up the case too. You kind of lift on it, pull back, because it's got this lip that goes into the plastic. There's no speaker or anything in here, it's just a piece, which is nice. Okay. Now we have these right here that are blocking what we need. In fact, I think our oscillator's right here. Let's see. Really don't want to put it down on its face. Yeah, I'm probably gonna have to. So they're usually stuck right here. There's something in here, I can't remember what it is. It'll feel like it's stuck. But trust me, it's not. But you can end up bending the case if you're not careful. It's this glue right here where they put some fuzzy crap, and it sticks to the case every time. I seen this issue on the other radio I owned, and I couldn't get it open, and I thought I was going to break it. Yeah, this is gummy. Okay, we want this off right here. Or we need to put a piece of tape over it. So, moving in here, you'll see I have one optional filter here. This is CW1, so these two here and there would be, I think, the only ones that you would have. The alignment manual would be good to have. But I'm pretty sure. Let's see. Okay. I just want to pull this up really quick and see what they were showing for, like, maybe filters. So these are all optional filters. So normally this thing would only come with 3 filters. That one, and that one. So these are all optional. I have the Collins mechanical filter, which is, it looks like whatever an XF115C is. It says Collins mechanical filter, YF. Now one of these was formerly called something else. These are all called YF. But they're now XF. Okay, so this is what we wanted to know here. The TCXO mounting location. Okay. Temperature compensated crystal oscillator is the heart of the master oscillator reference oscillator used throughout the transceiver. An optional TCXO unit is available for installation. The TCXO 6 replaces the factory installed TCXO unit, and it provides enhanced stability. If you also have the optional, if The optional YF115 sub receiver filter. Now would be a good time to install it. Interesting. So that YF115C is also an optional sub receiver filter. Okay, we need to look and see. Let's see. That's the. There's just a blank board on mine. It just says reference unit, and there's nothing on it. So mine is completely blank. Interesting. Okay, so what it says is it replaces the factory installed TCXO. So there is a factory installed one, and I guess apparently that's not as good as another one that you can buy. So I'm trying to figure this out here, where the regular one is. This contains the installation procedure for additional options of the Mark V FT1000MP. But this is not the field, and I don't know if there's a difference. Temperature compensated crystal oscillator is the heart of the master reference oscillator used throughout the transceiver, period. An optional TCXO unit is available for installation into the Mark V FT1000MP. The 0.25 parts per million TCXO replaces the factory installed unit, and it provides an enhanced frequency stability compared to the standard 0.5 parts per million. So literally, we're talking about 0.5 parts per million versus 0.25. It's not really a lot of gain. It's double, but it's still, like, seems like not really a significant amount. And we see here, though, there's this filter here. Now, the old radios had an adjustment right here. Well, and if you had that oscillator, you could adjust it there. So these new ones, I don't know where they adjust at. Because the board right here actually has a plug on it, but I think it's just a dummy board. And it says reference unit. But we're going to have to figure out where the hell the other one was at. Now, there's another receiver in here, and I don't know what that filter would actually work for on the other receiver, probably just CW. So you can see they're showing you the cover of a 200 watt version radio. So this 115C can go there, or it can go over here. Now the 115C is a 500 hertz bandwidth, so it's a CW filter. All right, we're going to look over here where it says reference unit and just see what page that is. 6J1. Some specifications. Okay. Exploded view of the parts. Well, they show the TCXO over here. Okay. Alignment. Preparation and precautions. Carrier frequency. Refer to the drawing below for the reference unit component location. Connect the frequency counter to pin 3 of J4703 and confirm the frequency reading to be 10,4,8,5,7,6,0 plus or minus. And that's on the reference board. Okay. So now that's just the reference unit. TCXO unit and test and alignment points. Where the hell's the alignment points? Okay. Connect frequency counter to pin 3. Confirm the reading of 10.48. And it shows down here. J4701. Pin 3. Wherever the hell that is. Carrier frequency. Connect frequency counter. 1.485760. I don't know what they're showing here. It looks like it's supposed to be that board, but that's the TCXO unit. This is the reference unit. There's no adjustments on it. At least not that I'm aware of. Let's go ahead and pull this thing out of here. We'll just see. Maybe there's something on the back of the board. I kind of doubt it. I think it's just a dummy board, but maybe I'm wrong. Alright. Last screw. Oh, wow. So it is on the back of the damn thing. Yeah, that's a TCXO for sure. Alright, how do you adjust that? You don't. Good lord. Oh, is that like a little frickin' tiny thing on the back of it? Right there. It must be. God, that's going to be a pain. That doesn't even look right. I'm going to unplug this. Doesn't even want to unplug. Gotta use these hard to unplug things. Alright. I guess that's a trimmer. Okay, so what do they say in here? They say J4701 pin 3. I don't know where that's going to be. This is J4701. Well, I don't know where J4703 is. So the reference unit is somewhere else. You got 2 brown wires. We got a gray wire going elsewhere. It's a good question. Refer to the drawing below for the reference unit, component location, and alignment points. They're not showing you any alignment points. Okay. What do we got here? And what did it say it was? 4703. If 4703 is not on here, now maybe they're referring to the optional TCXO. Okay, I don't see anything on this page here. There's just PLL loops. Squelch, S meter, noise blanker. What are we talking about? The local unit. Okay. So, don't see anything on here. Here's the PA unit. A low pass filter unit. Tuner control. IF unit. There's the main board. What's this? This is the, I don't know what board that is. Interesting. Alright, well, I don't know, guys. It's not a real thorough indication of what the other one is. Alright, here's a diagram of the reference unit. And what do they show here? Okay. So that seems to be a regulator. So you'd have to adjust this thing here, the reference unit. And interesting. Alright, I'm gonna flip through the table of contents really quickly. We got the reference unit 6J1. Okay. So do they identify any of the parts? So that reference unit is really the TCXO. And if you... Okay, so what are we looking at here? It said 6J something, but this is 2.4. I don't know what the 6J means. Because right here they start talking about it. The reference unit. Okay, they tell you what you need. So carrier frequency. Refer to the drawing below for the reference unit component locations and alignment points. Connected frequency counter to pin J4703. Okay. Well, let me get this radio powered up and we'll try and do that. And let me reinstall this board. Okay, so it says 50 ohm dummy load and inline watt meter must be connected to the antenna. All procedures that call for transmission except for when specified otherwise. Correct alignment is not possible with an antenna except where specified otherwise. Transceiver should be tuned to 14.2. We're going to do that. Okay. And upper sideband mode, obviously. Okay, MOX, VOX, AGC, processor, IPO, ATT off. Okay. Mic and RF power, fully counterclockwise. Notch and shift set to 12 o'clock. Reach each step to determine if the same test equipment will be required. Read each step. If not, remove test equipment. Before proceeding, correct alignment requires that the ambient temperature be the same as that of the transceiver and the test equipment, and this temperature be held constant between 68 and 86 degrees Fahrenheit. If the transceiver is brought into a shop from hot or cold air, it should be allowed time to thermally equalize with the environment before alignment. Alignment must be made with the oscillator shields and circuit boards firmly affixed in place. Okay. Connect a frequency counter to pin 3 of J4703. We don't have J4703 on this board. We don't know where that is because this is 401. I wonder if it's a typo. I got 104858. Let's see. 10485760. So I've got a couple of frequency counters. I don't know if that one works. So they're showing pin 3 of J4073. And down here it says J4701. And this is a different reading. So 10485760. I don't know how accurate my counter is. But what's this 401? Pin 3. Connect frequency counter 1.4. Different frequency. I don't really know what they're talking about here. The manual is not making sense to me. 10-4-8-5-7-5. 10-4-8-5. 10-4-8-5-7-3-6. Okay. 4-8-5-7-6. 4-8-5-7-6. 4-8-5-7-3-5-9. Alright, so the test point's right here. I've put my meter on hold. 10. No. It looks like we'll have to not hold it. It takes a really long time for it to change, because when you're reading hertz, the gate doesn't hardly ever flash. So we're looking at 10-4-8-5. Okay, we don't see the 1, but 4-8-5-7-3-6-3.3. So I'm not sure exactly what the resolution is there. So we want to see 10.485-760. 4-8-5-7-6-0. 60. So that 36 should be 60. And it could be off by plus or minus 5 hertz. So I think the last digit is the hertz digit, and then like the decimal is even less than that. So this is actually reading pretty well. We could try the HP and see if we get a different reading. I know that the radio is off, and it's off only by a very, very little. We might not be able to adjust this anyways, but that's where we're at. Let me try to put the hold on. Okay. I'm going to take my finger off the probe and see if it changes, because it did last time. So we have a 1 over here. That's a 10.485-7, and then we want 6 and a 0 or a 5. So we're low by about 9. So as I counted, it's off by about 90 hertz. So this does appear to be pretty damn accurate. Alright guys, so that's what the number we got on this one. 485-689.7. 485-736. So we're just off a little bit. And this thing's definitely blown up. It doesn't work. It doesn't read anything. So this is too bad, because this is like really high quality stuff. But yeah, it does not work. So the Heathkit and the HP work. I can also try that. We might read it. Alright, let's see if we can pick anything up with this. Okay. So it automatically pulls up 3.6 volts AC RMS. Now, it doesn't give us a real exact frequency. As you can see, we see 10.486. So that's the problem with a scope like this. 10.486, but that's good enough to tell us that we know we're too high. We need to be 10.48560. So it's doing its job. We don't have any other way to really read more than that. You can see here it's actually unstable on this screen. But it's just off by a little bit. So that's why I don't really care for this scope. But what's nice is no matter what, if, like, let's say we weren't using this, we could still come in here and be able to see that we have a waveform, and we can see that it looks good if you see that it's not doing anything weird. And pull the scope off of it. So that's good right there. So that tells me that it's 10.46, and we can't see any further than that. All right, so basically, the best I can do is either I can monitor that, I can go on to another radio, I can look and listen for the sound to be off. So 4.857.6. We want it to go up to 6. It's going to respond extremely slow where I'm at. We wouldn't even see the change, so 10.4.857.3. 9. Okay. So we want. Now you see, as you don't look as much resolution, you can see 10.4.857.4. I don't know if I can get this thing to change. Literally barely touched it. And we're at 6.7, so let's go back up. 10.4.857.58. We're really, really close. We don't know how accurate this thing is. So let's try. We want to 14,200. Okay. Let me get a microphone over here. And let me also disconnect this. I don't want to get RF into it. I got too many fucking noises going on here. Alright, antenna B was on the dummy load. Okay, that's in fact on the dummy load. Okay. We need the RF gain up. Need the mic gain up. One, two, 1, 2. I need to increase my power. 1, 2, 3, 4. 1, 2, 3, 4. Alright, we're gonna listen for the 0 beat. We'll put it over here. It's pretty close. Alright, let me Let's see. So now it reads a little low. So we're at, man, we went too far. Even though our display doesn't show that. So we can literally do this by ear. I'm going down over here. I'm on 80. And I'm going to go to 80 on here. You hear how that's perfect?
1, 2, 3, 4. Hello, 1, 2.
Okay. What we need to see is 10 meters. 28,430. We gotta adjust this back down to 0. Okay.
1, 2, 3, 4.
We went too far. We're 28,42965. We're lower than we were. The only thing I can think of. Oh man, I just turned this thing big time. We can hear it. That's 0 beat. So that's the method that I like to use. Unfortunately, I just 0 beated it to the wrong fucking frequency of the radio.
Hello, 1, 2, 3, 4. You can hear the difference.
So we're off frequency because I tuned it to the other one. Okay, that's pretty close.
Hello, 1, 2, 3, 4. Kilo Golf 7 Hotel Victor Romeo testing.
Okay, so you hear that that's very, very close. But the problem is, I think we'll lose 80 meters. A little bit.
Hello, 1, 2, 3, 4. 1, 2, 3, 4.
So you're basically going to end up splitting hairs.
Hello, 1, 2, 3, 4. 1, 2, 3, 4.
It's pretty close to 0 beat. So that's my method of doing this. We can put our counter back on here and see what the number is we actually got. Because that we know our counter's not accurate. So I got 10, 4, 8, 5, 7, 7, 1. Now let's see. 4, 8, 5, 7, 6, 0. So 4, 8, 5, 7. Let's go even further. Okay. Let me get my piece of damn paper. I'm not remembering things today. And I want to know what that other damn frequency is for. That's kind of strange. Let me see if I can find a pen over here. Okay. So right now we're at 485,771.4. So 485,760. Now let's just see if I just adjusted this to that out of curiosity. So we have gotten it 10,485,76, and that should be a 0 plus or minus 5 hertz. Okay. And if we go here, we'll get even further resolution if we sit and wait. Anyway. It takes a while for it to read. Four, 8, 5, 7, 6, 1.7. So I'm about as close as I'm ever going to get to that. The gate flashes like every 30 seconds on this. So as long as what you're looking at is pretty stable, you can get really high resolution, but you won't be able to change it and see it change. So let's try the radio again. All right. We're on 3.852. I don't feel like that's really changed enough to worry about it.
Oh, 1, 2, 3, 4. 1, 2, 3, 4, and then...
Okay. What we need to worry about, though, is 28 megahertz. 28430. And I think this is where it's going to be wrong.
Alright, 1, 2, 3, 4, 1, 2, 3, 4.
So what I need is the most accurate possible radio in the world. And it ain't either one of these. My 3000 could be off. So I'm going to grab a different radio. So I don't know if you guys can see that, but I have the Yaesu 891. Now, I think I trust it a little bit better.
Hello, 1, 2, 3, 4, 1, 2, 3, 4.
So let's see if I can adjust this.
One, 2, 3, 4, 1, 2, 3, 4.
Let's see what frequency we're on now. Okay. 10, 4, 8, 5, 7, 6, 9.6. So we know this thing's off. It's not good enough for precision work, unfortunately. Now, all radios can be off by quite a bit, especially when it takes a while to warm up. But I think that the 891 has a TCXO and all that good stuff in it. And I think it's like more stable than this radio itself, even with updates. So the problem with the 710, to try and test that, it won't zero beat because there's latency. So the delay between the actual transmit and the receive will cause the zero beat to not work correctly. So let me demonstrate what it will do. Okay. You hear the echo? Echo. 1, 2, 3, 4. So let me go to. It's about impossible with this radio. Hello, 1, 2, 3, 4, 1, 2. Now, if we go, let's go. I can't read the damn thing. Alright, it should be. What we got going on here? Hello, 1, 2. Three, 8, 5, 2. Hello. Hello, 1, 2, 3. What do we got going on here? Hold on. It was on upper sideband. Hello, 1, 2, 3, 4. So the only other radio that I can really test would be the 7300, and it might work. I don't think it does, though. Alright, let's go ahead and try this. We get, alright. Okay, so this is another reason I don't like the Yaesu compared to 7300. 7300 doesn't have that latency. Hello, 1, 2, 3, 4. Hello, 1, 2, 3, 4. No latency. I mean, if there is, it's very, very small. So what we're going to do... Let's move it to where it's going to pick it up a little bit better. Okay, 28430, 430. Okay. I can't get it on this.
Hello, 1, 2, 3, 4.
It does have some kind of latency. It's just not as bad. Okay, that's the 891. One, two, three, four. 1, 2, 3, 4. 891. We'll turn that one down. Okay. In the 7300, we can really see it on the scope right there. Let me bring my power up a little bit. It looks like we're all the way up. What am I showing on this meter?
1, 2, 3, 4. 1, 2, 3, 4.
Okay. Let's just go to... Okay, so we have 10, 4, 8, 5, 7, 6, 9.9. It'd be nice if that was more accurate. But I think that we've got to be very, very close to our actual goal, which means that we could actually probably calibrate our damn counter if we really wanted to off of this. What I need is the actual, like, dedicated, 100% accurate reference, and then I could get my frequency counter dialed in. It's going to deviate a little bit. So, what we're learning here is that accurate equipment is really important for this. Otherwise, you got to do it different ways. So, okay, we got 3852, and we need to go here. 3852. Let's just see what we sound like on the 7300.
1, 2, 3, 4.
And that looks pretty good, sounds pretty good. I can see it on the scope. I'm sure you guys can too. Let's bring it in a little closer. It's off. Okay, now let's try it on the 891. It sounds off to me. 3852. Okay. Yeah, it's off. What did I just do to the radio? 1, 2. 1, 2, 3, 4. It's pretty close though. I guess that's as close as you're gonna get. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, no, that sounds 0 beat. It's just really hard to tell. So we could try a couple of other radios just for the sake of this video. Alright, we could try the 450D. Let's see what the volume is. Alright. Sounds good to me.
Oh, 1, 2, 3, 4. 1, 2, 3, 4.
The only other radios I have that are like new are the Zygo G90 and the 6100. Other radios that I have are older. It could be off. Like the FTDX 3000 was off when I got it. And I made the mistake of calibrating it to my ICOM 746 Pro. So I don't know if it's actually close.
Hello, 1, 2, 3, 4.
Okay, we'll go over there and then we'll go 28 band. I mean, but most radios shouldn't be off. For some reason, I'm just gonna. $430. Okay. We need mode. Must be noise blanker on. I would say it's a little bit off. According to that radio, it's off. Oh, 1, 2, 3, 4. 1, 2, 3, 4. It's going to be really hard to say. One, 2, 3, 4. 1, 2. I mean, it's close enough. And this radio is cold, so it's hard to say how accurate that is. But yeah, it's amazing, you know. We take for granted how accurate most of these radios actually really are in the first place. I mean, back in the day, I don't think it was as much of a problem because we didn't have accurate digital readouts, so you didn't really know unless it was really, really bad. Here, the display is just a readout. It's not a frequency counter. And so they did that. They did away with that on purpose because the radios were drifting. And the frequency counter was telling on them. So what they wanted to do was get rid of the frequency counter and use a digital display. And therefore, they didn't have anything reading the frequency. It was just a display that tracked with the rest of the radio. So, some of the earlier radios, the whole thing was that frequency counter. And other ones, the last couple of digits were, and then everything else was band switched. But when they did that, you could see the digit drift back and forth on some of the radios. And that was why some of the earlier radios, they didn't want to show that other digit because you would know how inaccurate the radio really was. It was, you know, they couldn't convince you that it was stable. Like ICOM 761 didn't have the extra digit, although the display is just a display, not a counter. But that was because back then the standard was to not show that digit in case it drifted. On stuff like the Kenwood 820, the 830, there was an extra digit on the display. They chose not to use it because they didn't want you to see it. The Yaesu 102 has an extra digit on the display. They didn't want you to see that either. The 101 ZD has an extra display digit. The 901 DM has an extra display digit. They don't want you to see it. It'll drift. And it'll be moving around like crazy. I mean, you know, you'd be on 28.430 point whatever, and you'd see that move probably 200 or 300, which is way more than what we're trying to even calibrate this thing for right now. So, anyway, guys, that's it for me. This is about as much help as I can be. with this. If you don't have a super accurate frequency counter, you're never going to be perfect, and you're going to be going by ear off of another radio that might not be perfect. So, but it would get you in the ballpark, and if the radio is bad, you'll get it to where it's not bad. So I hope that helps somebody. Thanks for watching.